Hello, and apologies first off for the delay as we deal with some internet connectivity issues. We did have a pretty severe thunderstorm in the GTA last night, and I'm going to blame that for our internet connectivity issues because that seems like a logical explanation. My name is Rashid Clark. I'm the marketing specialist at the Riverwood Conservancy, joined by Dave Taylor, our education program director. And thank you so much for tuning in and joining us today for our discussion on dinosaurs changing images. Again, sorry for the delay in getting things started, but we will get to the presentation and, of course, to all of your questions as we go along today. So thanks so much for being with us. I hope that you're doing well and staying safe at home. Since we've already, eaten up 10 minutes of your time, hopefully not just waiting, but we'll turn things over to Dave now, who is a wildlife photographer, author of more than 40 books on wildlife and ecology, and of course, our education program director as well at the Riverwood Conservancy. So thanks so much for tuning in. If you have questions for Dave throughout the presentation, just type them into the comments section. We'll get to as many questions as we can after the presentation. And thanks again for tuning in. So Dave, I'll turn things over to you.
To me?
Yes.
I'm having difficulty hearing Rashid, so I apologize if I'm interrupting him. It's been frustrating the last 10 minutes or so, but here we go. We'll see what we do. We're talking about dinosaurs today and their changing images. And I want to start out by going back in my lifetime when I was a very young kid and received this book. Some of you may have seen it. It's called Prehistoric Animals. I got it when I was about 6 or 7 years old. And I found it really interesting. I'm not sure if you're seeing full screen or we're still sharing with Rashid. However, one of the pictures in there was of this dinosaur, T-Rex. I'm going to hopefully hold it up. And that dinosaur was exciting because it was big and it was horrific and scary. It wasn't much more than that. Didn't have much of a life. It was kind of a boring critter. It wasn't exciting. And I think as we grew older, we kind of grew out of those things. So this little model would be the kind of dinosaur that one in the picture represented. And then we come to the modern day T-Rex, active, dangerous. And the question is, how did we get here? How do we go from that 1950s dinosaur to the 2020 dinosaur that we know today? It's gone through a lot of changes. When dinosaurs were first discovered, we didn't know much about them. They thought they were lizards based on their skull and their features. But one of the things that they decided was, since they were lizards, they had to have their tails drag on the ground because that's what lizards do. And so dinosaurs were mounted this way. And it wasn't until the 1970s, I've just lost picture here, when the dinosaurs got brought back into the future. Hold the slides for a sec, Rashid.
Yes, they are. But Dave, we unfortunately seem to have lost your picture. But if you can still speak, please continue on with your presentation.
Okay. Well, it's going downhill as rapidly as possible. Hope everyone's enjoying this meltdown on air. The picture that you're seeing, I'll talk about it, represents one of the big findings that changed the way we understood dinosaurs. This is a bird called Archaeopteryx. And for years, it was thought to be the first bird. What we now know is it wasn't the first bird. It was one of the first flying dinosaurs. It had all of the features of a dinosaur, except it happened to have feathers. And you can see on the picture the imprint of the feathers. Can we go to the next slide?
We sure can.
So in this picture, this is a more recent finding from China, and China has been giving us remarkable fossils. And the fossils were preserved in sandstone and clay, and they preserved a lot of detail, including the loss of the tail in this dinosaur and the replacement of it with long tail feathers. And you can clearly see that this is a feathered dinosaur, and probably a flying dinosaur. So now with Archaeopteryx, we weren't sure if it could fly or glide. Now we are in a position where we're pretty sure that these ones were flying. And they weren't much bigger than, say, a crow. Next slide, please. Next slide.
Should be up
I'm
on
going to
screen.
start singing.
No, it's up on screen now, Dave. There you go.
All right. There is the Archaeopteryx as it's been restored to life. You notice a couple of features on this. It has teeth. It also has claws. And it has a tail. And out of the tail, the feathers are growing. So it wasn't by any means a good flyer. So you have to ask, why were the feathers there? Well, one of the things that has changed about our understanding of dinosaurs is we no longer think of them as being cold-blooded. We think of them as being warm-blooded animals, and feathers would help keep that warmth in. The other reason they could have feathers would be for display purposes. So imagine the Archaeopteryx when it's displaying to a potential mate or potentially a predator to make itself look larger. It spreads out its feathers and wings and raises them, and just like a peacock might do, to scare off and intimidate or to romance whatever its goal was. The teeth would be lost eventually. And it is just in the last few years that they have found a very large dinosaur. It was a plant eater that started out with teeth as a youngster and had them for maybe a few years and then lost its teeth. The thinking has always been that birds lost their teeth to lighten the load, but maybe there are other reasons behind that. And so dinosaurs are causing us to ask questions about that. Next slide, please. That process.
Might take a while for you to see it on your end, Dave, but it is up now.
Okay, so this is the original T-Rex, and I have some models here, which if we get a chance, I'll show them to you. This T-Rex is unfeathered, and nobody was picturing it feathered. Certainly not Steven Spielberg in Jurassic Park. Not even the most recent one, Jurassic World, has the T-Rex sported feathers. But what has happened in the last decade is that they have found members of the T-Rex family. The Tyrannosaurus Rex is a member of the Tyrannosaur family, which has probably more than 50 individual species in it. And some of those species have been found fossilized with feathers. And as a result, can we go to the next slide? We are starting to reimagine that T-Rex the way this next picture will look. Feathered. Now, whether it was as feathered as the one I have modeled here is questionable, but they were feathered, and probably as they got older, they tended to lose the feathers more. So there would be more flesh showing, more skin showing. But the feathers would have served a variety of functions. Now, we're going down this road of bird connections. Is a T-Rex a bird? Well, no, a T-Rex is not a bird, but it is classed with birds now. In fact, birds technically don't exist anymore. They've been classified as avian dinosaurs, class Ava, and we'll talk to that in a bit. That class of dinosaurs includes all of the theropods pretty much, and the theropods were mostly meat-eating dinosaurs like T-Rex and others. Allosaur is another one you might know, but it also included several smaller animals, much smaller, some of them as small as a chicken, that were unable to fly, but still went through life covered with feathers. One of the things that perplexed me as a kid was why are we so sure the dinosaurs died out 65 million years ago? 65 million years ago, the theory goes that an asteroid came in and hit the Earth down around the Yucatan Peninsula in Mexico. Came in at an angle about 65 degrees. And it came in such a way that the blast from that blew the debris across all of North America. North America at that time was divided in two an eastern and a western section by an inland sea. When that asteroid hit, it put up tidal waves and huge amounts of ash and debris into the atmosphere, which basically wiped out all of the dinosaurs almost instantly, North America at least, up to at least the Arctic Circle. But then things got worse, if you can imagine things getting worse. There was so much ash in the atmosphere that it could have taken, some people guess, upwards to 1,000, maybe several thousand years for the skies to clear. And during that time, the Earth was plunged into a very cold, dark time. Plants don't do well in cold, dark times. So 75% of the living things on Earth died out. And the large dinosaurs, including all of the non-avian dinosaurs, became extinct. But somehow the avian dinosaurs, the ones we now think of as birds, they survived, along with turtles and snakes and small mammals and some animals in the ocean. Probably it was due to their small size. Can we go to the next slide?
We sure can.
All right, so let's talk about avipods. Behind me on the desk that you can't see, I have the skeleton of a snowy owl that was donated to our education program. This is a skeleton of an avipod. I'm not going to even try to pronounce these animals, so forgive me for that. But there are certain characteristics that are similar. Walking on two legs, the long forearms, the fingers, the mobility, and the fact that it was a predator. These are characteristics of avipods. Can we go to the next slide? That modern animals like robins, whatever, share. They ranged in size from the T-Rex to much smaller than the chicken. Like, there were actually theropods not much bigger than the common house sparrow and living during the time of these big dinosaurs. So the traits were a long pelvis, long legs, typically 3 forward-facing toes, and you can see that when you watch an ostrich walk, when you watch a robin hop around, those 3 toes, and then 1 facing backwards. That toe facing backwards in birds is really important, especially in passerine birds, because when they land on the tree, the front 3 toes, tree branch, wrap around, and the back toe wraps backwards, and they have a little muscle that locks them in place so that the bird won't fall off the tree. It can stand there. They have a bird-like air sac ventilated respiratory system, and that was either present or developing in them. The pneumatic skeleton, which means the bones tended to be lighter. So a T-Rex weighed less than you would think it would weigh because of the lightness of its bones. And then the way they moved was distinctly bird-like. Can we go to the next slide? So here you can see an example of two, a large theropod and a small theropod. They're definitely related. The neck, the chest, the legs all show you that these animals were predators and related to birds. A little word about predation. There's been a lot said about the T-Rex and whether or not it was a predator or a scavenger. I think people that are debating that are wasting their time. I think you could take a look at a lion today, and while we would all clearly say that a lion is a predator, the lions that I've watched in Africa often are scavengers, stealing from hyenas or cheetahs or other animals that have made a kill. But they're still capable of making their own kills. I think the T-Rex crossed over that boundary. It was probably both. It wasn't as fast a runner as it may appear in Jurassic Park, but it wasn't a slowpoke by any means either. And why the small arms? No one is really sure, although it is quite likely that as the animal became more mobile and was able to bite and kill its food didn't have to catch it anymore, and that's one of the reasons they think it might be a scavenger. The arms probably served a purpose during mating, although who knows? Next slide, please. One of the amazing things about dinosaurs is the color. We were taught, and by we, I mean anybody that is upwards of 100 years old will have been taught that dinosaurs, we could never know their colors. So this example of this dinosaur gliding after a dragonfly was just my imagination. I thought it would look good in those colors. We go to the next one. This represents its true colors, the red, the white, and the black. And one of the more recent scientists was doing research, I think it was Michael Benton, and he discovered these little things called melons that are fossilized. And he did start doing some research on it, and he realized that these things, which give living things color, also fossilized. And if he could identify them, he could say with some accuracy what color the dinosaur was. And so for some dinosaurs, particularly the flying ones, we now know that they have these colors. And so this flying dinosaur was black, white, and red. And because of where they found the traces in the fossil, we know that the feathers represented here would represent pretty close to what it would have looked like in life. Next slide. Let's talk a little bit about feathers. When we talk about feathers, don't think of feathers the way you would think of a robin feather or an eagle feather or the feathers in a headdress or on a dress. Feathers come in all sizes and shapes, even on a robin. And some of them are very tubular and look like hair. And on this picture, you can see a picture of an emu and a kiwi. Both are ratites, which means they're flying flightless birds. They're found in the southern hemisphere, and their species, their family, survived after that asteroid hit and would evolve into the ratites we know today, which include the ostrich. So their feathers are not feathers designed for flying. They're feathers that are designed to do the same sort of thing that the hair on our heads do. Keep us warm, protect us, and probably help make us more attractive to potential mates. Next slide. So as we've evolved in our understanding of dinosaurs, we've also evolved in understanding of feathers. So this raptor that you can see here is sporting flight feathers on its arms, although it was truly not capable of flying. But it has these more tubular feathers covering the rest of its body. The colors, when this model was made, were an educated guess, but they probably are fairly accurate. Next slide, please. This is one of the largest animals that they found that weighed almost 5 tons, rather, 12 meters high. This one, they did find feathers with it, and they know that it was pretty much feathered up to the neck. You notice the teeth? This was not a flying animal, thank goodness. It walked on 2 feet. It was very awkward, and no explanation for the claws has really been put forth that I've seen, but who knows? It could have been using it for getting fruits. Next slide. These are some other examples of feathered birds or feathered dinosaurs from China. Next, please. So all of these things that we've learned about dinosaurs, including just recently a remarkable find of a dinosaur so small that it was encapsulated in amber. You can imagine bees and mosquitoes and other insects being caught in amber, but this thing would have been smaller than, I believe, a sparrow. And another interesting thing, when we think of dinosaurs, we often think of these great flying reptiles, the pterosaurs flying overhead, some of them standing as tall as a giraffe, and all of them capable of flying. They didn't have feathers. They did have hair, or very hair-like feathers. But they have found a dinosaur that did not have feathers on its wings, and like a bat, had wings that were connected to its elongated finger bones. Now, this dinosaur wasn't very big, but it was experimenting with flight in another way. And so you have to ask yourself, what roles did dinosaurs play? And there were back in the day, no flying dinosaurs. We know that dinosaurs were flying, probably at least in the last period, the Cretaceous, and probably in the Jurassic period. We now know that they had developed into more bat-like animals. And that raises the whole question of ecosystems. How did they live? What did they do? What was this world like? One of the exciting finds that was made about 30 years ago were large colonies of nesting dinosaurs. And then they found some of these dinosaurs actually fossilized on top of their nests. And then they realized that they were feathers, and that just put another link into the bird-dinosaur relationship. So we know that they nested in colonies. Well, birds that nest in colonies tend to nest within pecking distance of their relatives. They tend to have to defend them against predators. And suddenly you're starting to evolve in a whole ecosystem. A whole world is coming into focus where these animals were not just bones in a museum. These animals were facing the same problems that terns faced down on our lakeshore, bald eagles face. Next slide, please. A close relative of birds and dinosaurs are alligators. They all are members of the archosaur family. Used to be, when I taught this back in the 80s and 90s, we would teach that birds and alligators were closely related based on their skull features and based on things like nesting behavior and the fact that alligators will help raise their young and protect their young. Well, now we know that dinosaurs do the same thing. Next slide. Next slide. This has got to be a lot like driving a car blind. Okay.
How about now, Dave?
There we go.
Okay.
All right. One of the other things that they found is that these dinosaurs, some of them lived underground. And this led to a whole new study. Dinosaurs aren't supposed to live underground like groundhogs and moles and voles and things like that. But here they found fossils of this particular dinosaur with its eggs and its youngster in cavities that it has burrowed underground. So we have dinosaurs playing the role of groundhogs now, emerging maybe at night to feed. Were there dinosaurs that hunted actively at night? Well, we don't know. But it's an intriguing question, and it's a question that is leading us to look for dinosaurs in evidence in places that weren't places that would have been searched in the past. Next one, please. Dinosaurs laid eggs. They laid them in clutches, and they laid them in different patterns so that you could identify the species by the pattern. The eggs were fairly modern, but what happens when they hatched? Next slide, please. Well, we now know that some dinosaurs brought food to their babies. Other dinosaurs probably didn't. Next slide. So the Canada goose, for instance, raises its young, and the young follow them. But other birds, they just pretty much wander away from the nest very quickly and must go and fend for themselves. They're not getting any food, like, well, the Canada goose again. But a robin, for instance, babies have to be fed in the nest. Well, the maiasaur, means good mother, it brought food to the nest. They found the fossilized food. Other dinosaurs, probably like T-Rex, maybe left the nest almost immediately. But did they just go off and fend for themselves? Probably not. Now, there's a terrifying picture. Next slide, please. Imagine a T-Rex, mom and dad, accompanied by their babies wandering around. And then you got to ask, what did the babies eat? So baby crocodiles eat very, very small food because they certainly can't eat a wildebeest or a deer. So what did these animals eat? Next slide, please. So we have these evolving stories. Now, one of the things that has opened up the world of dinosaur life to us and answering some of these questions are trackways. These are the tracks of great blue heron in mud. Next slide, please. This is a grizzly bear track in sand. Next slide. And these are dinosaur tracks. They look like they could have been made yesterday. They're down in a place in Texas that's famous for its preserved tracks. These tracks and these trackways are starting to really tell us. There are places where they have kilometers, of trackways. They have, next slide, please, tracks of sauropods, like the big brontosaurs, these long-necked ones, being trailed by predators. And it's just an amazing story. And you know what's missing from these trails is tail tracks. There are no tails being dragged behind them. And this goes back to back up this notion of how we've seen the image of dinosaurs evolving. Now, I think I'm going to stop here. We could go on. I know there's some questions. I hope there's some questions. And I'm happy to take the questions. I hope you enjoyed watching speaker do a meltdown on live screening. So always entertaining. I know when it's happened to me doing live presentations at Riverwood, I think that was probably the highlight of the evening. So I hope you enjoyed that part. So questions, Rashid?
Hardly a meltdown, Dave. I think people will be understanding of the fact that we are dealing with technology here, and technology is imperfect. So we'll first of all say thank you for the presentation, and thanks to everyone watching for bearing with us as we went through, not as we had planned, but still got a lot of great information out there. And Dave, thank you for that. And so yes, we will turn to your questions now. Any questions that you do have for Dave, please type them into the comments. We'll get to them as we go along here. And Dave, I don't know if you can see the screen, but I will certainly read out the questions that we have.
Thank you.
One from Trisha. Do prominent dinosaur paleontologists like Robert Baker and Jack Horner support current theories of feathered theropods?
I have not read, honestly, anything that Robert Baker or Jack Horner have read recently about this. But since they were at the forefront of questioning them, Robert Baker wrote a book that changed my life. I have it here, and I'm holding it up. If you could see it, you would recognize it. It's called Dinosaur Heresies. Now, Baker wasn't the first one to suggest that dinosaurs were warm-blooded. He worked with another famous paleontologist. But Baker was the first one to write a book that was accessible to people. And when I read it, it really changed my attitude about a lot of things, not just dinosaurs, but about teaching. We take so many things for granted. We get into this dogma of this is the way it must be. And here Baker is saying this is wrong. Now, people rightly defend dogma. Scientists defend it all the time. But as more and more evidence gets compiled, people change their minds. I suspect that Baker probably has gotten on board. I can't imagine him not getting on board. And the same with Jack Horner. Jack Horner is very active in the Museum of the Rockies, and I know that they have many feathered dinosaurs on display there. So I would have to say absolutely. And those two people are my heroes. Jack Horner was the model for the scientists in Jurassic Park, And Robert Bacher was in the second one. He's the one that gets eaten under the waterfall with the big hat and the beard. So I think they have a sense of humor, and I think they have some enjoyment of the way they've affected life and our understanding of it. Yeah. Next question.
Next question. This one coming from Shane. Has there been any major dinosaur fossil discoveries here in Southern Ontario?
Shane, I wish I could tell you that there has. As far as I know, as of my research today, there have been no dinosaur finds any place in Ontario. There were rumors of possible dinosaur find up around the border of Manitoba and Ontario and Hudson's Bay. But that was several years ago, and I have not heard anything since. If you go to the Credit River, there are lots of fossils there, but those fossils are from 425 million years ago until about, maybe 400 million years ago. And no dinosaurs, because the dinosaurs would not exist for another 200 million years. So sadly, no. Next slide. Okay. Or next question. Question.
I wish we could get to the slides again. Next question comes from Jeff and Steph. I had heard on National Geographic a theory that T-Rex had small arms because its tremendous bite force needed a lot of muscles that were stored in its neck. So as a result, it didn't have large arm muscles, as they could have taken extra body space and weighed more. Any thoughts on this, and have you heard that theory before?
I have not heard that theory. I would say it's as good a theory as any. National Geographic certainly has put up done some really wonderful stuff, and really was very interesting when National Geographic sort of recanted a few years ago all of the stuff that they had said about dinosaurs in their earlier magazines and acknowledged the change. And that was a really interesting thing. That would probably happen about 25 years ago. So I do not know about that one, though. Next question.
Okay, next one coming from what was the biggest dinosaur, and basically in the world, what was the biggest one that we have record of?
I couldn't hear you, but I can read the question. It says, what was the biggest dinosaur? Probably still Brachiosaur, the one that's featured in Jurassic Park. This huge thing that emerges from the water and is eating the plants. There have been some predators larger than T-Rex. Spinosaurus is one that was featured in a recent Jurassic World movie. However, that dinosaur is not interesting for being so large. It's more interesting for being the first probable aquatic dinosaur that's ever been discovered. Dinosaurs did not enter the ocean. I've always wondered why they didn't. I know there were large reptiles in the ocean, but why couldn't there be dinosaurs in the ocean? Turns out there at least was one species or one family that was able to swim. So we'll see. Not a good answer to your question, but
well, we'll still we'll take that as a good answer, I think, and move on to a question from Renee. What is the most common fossil that we can find along the Credit River?
It depends where you're looking. So in Arundel and Riverwood, the most common fossil is probably corals. There seems to be a lot of corals down there. There are some other species found, but most of the time you're going to find corals down there. When you get further up around the forks of the Credit, you might find some trilobites, and that's just an indication. The rarest fossil, and it has been found in the Credit River, and it is fairly recent, like 60, 70, 80 million years more recent than, way more than that, is the fossil Ductleoctus. And Ductleoctus was this huge fish, bigger than a white shark, with a jaw that had no teeth, but sharp edges like a turtle's mouth that could open and slide back over the back of its head and open wide enough to feed you. Well, they have found pieces of it in the Credit River Valley. The main fossil from that was found over by Cleveland. So it speaks to a time when there were oceans that joined and covered our area. Next question.
This one coming from Cindy, going back to the color of feathers. So how would scientists have tested for the specific color pigmentation? How do we know what the colors actually were?
All right, there's two books, Cindy, that you want to read. And the one that I think is the best is on your question, is one by Michael J. Benton. It's called Dinosaurs Rediscovered. It's the scientific revolution in paleontology. And he goes into great length about the discovery of that pigmentation and how they know what it was and how they discovered it. And it is really good reading. And on the back of that book cover, there is a picture of the little dinosaur that I had shown in my imitation with the red and the white and the black feathers. So that's the book about that. It's complex and I can't remember it all, so I'm not going to pretend to. The other book I would highly recommend is The Rise of the Dinosaurs, New History of the Lost World by Steve Brusciati. Again, an American who's living in England, has done great stuff, made a really readable book. I would suggest either of those would be ones that you would want to check out. And if you're really, really into facts and figures, go to a new series of books called Dinosaurs, Facts and Figures. There's two, a new one being published. There's one on the theropods, which is basically the bird-like dinosaurs. They're just chock-a-block full of information about all these dinosaurs. Not the stegosaur, not the triceratops, but the T-Rexes and the flying ones. Excellent book. Recommend them both. I have about 100 books in my library on dinosaurs, which says something about me, maybe not particularly flattering, but says something.
I don't think there's anything wrong with having 100 dinosaur books in your library. And again, before we get to the next question, again, our apologies for the video connectivity issues with Dave, but he is obviously here, still on the line and answering your questions. So this one coming from Mark, do all dinosaurs lay eggs?
Do all dinosaurs lay eggs? I can see the question. As far as we know, all dinosaurs lay eggs. They have not yet found any dinosaurs with a baby, actually an embryo inside them. That's not to say that they won't. White sharks, we know, have their young hatch inside their bodies. There are several species of marine reptiles that are now extinct where they have found the embryos, even one example of one hatching when it was fossilized out of the body. So is there a reason why dinosaurs couldn't do it? I don't know of it. They just haven't been discovered. And I suspect at some point they will. But so far right now, the answer is yes. As far as we know, all dinosaurs lay eggs. Next question.
Okay, and this is more of a housekeeping question coming from Tricia. Will the full lecture be available to view, including the questions and answers, on the Riverwood site? Not quite on the Riverwood site, but certainly on our Facebook page. Tricia, we will have the full presentation, including this Q&A session, up on our Facebook page, and also we'll put the video up on our YouTube channel. So keep an eye out for that once we are done the live broadcast here today. And just a reminder, on our website, if you go to the riverwoodconservancy.org/riverwood@home, you'll find a whole list of our recent webinars and online presentations to keep you occupied and connected to nature while we all do our part and stay home in the middle of the COVID-19 pandemic.
I don't know if you're still talking.
And Dave, I think we are done for today. We've had a lot of questions come in, so I think now's probably a good time to wrap up for the day. Thanks everyone for bearing with us through our audio and video connectivity issues, and we'll wrap up for today and say thanks and hope that we have things sorted out for our next broadcast. Thanks again for being with us today.